All right, the diagram here shows the curve. Aha, what curve is this? They say the curve is y equals to root 3 root x, and the line is y equal to x. These are real passes, by the way. And intersecting at the points O and P. So find the coordinates of P and the area of the shaded region. Okay, two things are there. Aha, coordinates of P and the area of the shaded region. Okay, what I'm going to do is I'm just going to cut this across into an empty, what do we say, whiteboard. So I have a whiteboard ready here. It's just a paint, actually. It's not really a real whiteboard. It's just a theoretical one, I guess. Okay, let's resize it a little bit. So 60% or what? Oh, too small. Okay. Oops, sorry. Okay. Let me see if we can resize it to about probably 80% or something. It's a bit okay. Okay, so just to have more space. And here, okay, on this. All right. So let's think and see how to solve this. Okay, let's imagine the line is still there. Resizing, destroy that part. Okay, we just add that back. See here, the first part, the coordinates of P, maybe I'll do it separately. Let's say 3, 1, 3i. Okay. So when you talk about the coordinates of P is intersection, if you notice what is the meaning? The two curves, this is y equals to root 3x. So the point P lies on both curves. I mean, satisfies the y and x on both curves. That's the reason why we solve simultaneously. So what we need to solve simultaneously is, okay, let's see, y equals to root 3 root x. Let's see this more carefully. And then y equals to x. So it's a bit of a simpler equation, especially how you know that. Some other tips are when you see the intersection is 0. Because when it's 0, 0, that means the solution is x and y both being equal to 0. So that itself is an indicator that must be factorizable in some way, right? So we equate the two things. Aha, you know what I'm talking about. So 3 root x equals to x, because both are equal to y. So I just say equate it. It's to the y part and the x. Then please do not cancel out the x. That's a common mistake when they do this kind of thing. So 3 root x minus x, bring it one side. What can be cancelled out can be factored. Okay, so factor out the root x, because that's the lowest power of x. So this becomes 3 minus root x times root x is this. So it becomes root x only. In case you're confused on that part, also we can do like exponent. Means you take out x to the power half. Then you can think of it like 3 is there. It's a 1, right? 1 minus half. And then the other one, you take out a half once. Sorry, it's already half only. The half minus half. This is 1 minus half. Just a scribble. Sorry, scribble looks a bit bad. Sorry. So this will be 3x to the power 0 minus x to the power half. So in other words, is x to the power half. X to the power 0 is 1. So 3 root x line, x to the power half, blah, blah, blah. Okay, that's just another way of saying it. Either way, it's the same thing. And therefore, here we have root of x equals to 0, or the other bracket, is the number by itself, is 0, because only 0 times something is 0. That's the reason. And here we are. Let's continue this side. Let's see, like this. So if root x is 0, I might do down. Okay, change my mind. So x equals to 0 square, or here, just to show some working. So x root x is 3. So, you'll know how I'm working. X is 3 square. That gives the x is 0 or 9. Aha. So the x is 0 or 9 means now we just substitute back for the value of y. Use the easier one. Y equals to x. So y is 0 or 9. Oh, that means now we found the two coordinates. The coordinates of P is the one that's bigger than 0. So definitely we must choose this for P, which is, it is 9, 9. X and y are both 9. Let's take that. Okay, so let's just take a screen grab of this part. And then I'll clear. Just remember in mind. Just remember that it is 9, 9 now. Okay, if I say that, let's say that. 9, 9. Okay, the 3i, 9, 9. Okay. Okay, now I clear the drawing. So let's go for this part, the B part. So it's 9, 9 there. The coordinate I add like that from the part A. Okay, now they say find the area of the shaded region. So what is the area of the shaded region? We need to think a bit of integration on this. So integration is just summing up areas, small microscopic areas, to total up them to that. Okay, this is the straight line, right? Let's make it a bit more clear. So let's just change the color a little bit. So when we do integration, we must have in mind the two facts. Dot, 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 like that. Until like this. So that means this is a value of 9. X is 9 here. Lah. And then we don't need the other side, which I'm not marking that. So 0 to 9. These are called the integration limits. Okay, but we actually can use the other side to do a shortcut because this part is also 9 because of the symmetry, 9, 9. So the height and the base of the triangle. So what does integration do? Integration, kind of like when you integrate the green one from the curve, it pulls it downward all the way until it calculates the area like this. Area like that. All the way until that, the area. So that means the area of the shaded part, okay, area of the shaded part would be the integration of the curve from 0 to 9. So how the formula works is like how I put the arrows. So you take the x from 0 to 9, from however the curve is, from wherever the point there, the curve along the thing, it will pull all the green, light green area. That means we just write the equation of the curve, which is y dx, the green y. Okay, y against x dx. And then we need to minus the area of the triangle. So we need to minus the area of the triangle. So minus area of the triangle. So I just write it in words. It's okay to write in words. It's quite obvious which triangle is it, huh? Triangle. Aha. If you want to give a name to it, also can. Let's say OP. And then you didn't know what letter to put here, just simply add a letter for yourself. So you can write triangle OPR. Okay, being that said now, let's continue the integration and see. So that means this is integration of 0 to 9. See, the y is root 3 root x. So 3 root x, I'm just going to write it as x to the power half. Whenever we do integration, we're going to use the power form, because the law is based on that. And then here, the area of the triangle is half base times height. So half times the base and height of this triangle are both 9, because the vertical and horizontal coordinates are 9 respectively. So this becomes 9, 9 like that. Oh, so then here, what we do is, we just need to integrate. So we put this box whenever integrating an outer thing, there's a limit. It's a definite integral. So here, what you must do, the rule is plus 1, so half plus 1 over half plus 1. Need to divide whatever by that. This is the integration law. And then there's no bracket or nothing, so it's just 9, 0 like that. Here minus this, just please put in the calculator or just leave it as 81 over 2. A fraction is better. Not just any fraction, an improper fraction. Okay, a mixed number can be a bit, they don't really write mixed number in these kind of things. So just simplifying this is 3 over 2. So bring it up, this becomes 2 in the bracket. Okay, I just do fast that part, the simple part. So you just put in the calculator for being it correct. Yep. So this becomes 2, 2x to the power of 3 over 2. Oh, you can always check also by just, what is the word? Times and z, times and minus 1. You can see in your mind, it is the same thing as the original. Okay, then it brings us to the next part, just a substitution, a direct substitution. So what do I mean by that is, oh, this is 9 to the power of 3 over 2. All this you can just use calculator if not sure. Minus the integration limit, put the 0 instead in the place of x, you get the 3 over 2. And then this side is minus 81 over 2. Because some of these numbers are a bit easier, 3 squared, so it's going to be 2 times, what is the word? 27, 3 cubed, minus 81 over 2. So when we calculate that, we'll get the final answer. So this is just a calculated thingy. Okay, let's see what's the answer. Okay, let's calculate and see. 81 over 2. So we can leave the answer in decimal, is okay. Whenever there's an ending decimal like that, when the decimal digits end like that, they didn't write CM or anything, so that means we can't use that. So it's not really necessary. We can put unit square just to signify it is an area needed.